When I went to MIT, only half the students were intelligent. The other half were in the United States Navy, and I was one of them in the United States Navy. So, when I got out of MIT, I had already been in the Navy 5 years. I had been first a seaman in the Navy, and then after the Navy sent me to MIT, I became an officer. When the war was over, I was a lieutenant in the Navy. So I had both the MIT training and the experience of being a Navy officer. And that goes a long way at an early age to learning to be a leader. One of the views, if you're going to be a lead engineer, you're going to be what we used to call a project engineer. You're in charge. It fails, it's your tale. Real engineering is not science. It involves scientific principles. But engineering, let me interrupt myself and think, I hear a lot of people telling MIT students, you're going to learn a tremendous amount by your failures. No, you're not. You're going to fail when you fail. There is a difference between making a mistake and failing. For example, let us suppose you were a fighter pilot. What would you learn from your first failure? That you're dead. Now, the way you avoid failure is to anticipate that you could, which a lot of the people with their egos don't. And so you make a list of how you might be beaten by a competitor, how this part might not work, you might not get this on time, this mathematics may be wrong, what are you going to do if this goes wrong? And then if you do pay attention to all those things at the beginning, you succeed. When I went to work for the Eckert Mosley Computer Company, I was, let's see, in 1950, I went there in 1940, I was 21 years old. The first job he gave me was to design the standard gate for the unit. Now, the standard gate consisted of some diodes that went together plus a resistor. And they could not make it go fast enough. But I had taken a course at MIT on pulse circuits, and I knew that if you put an inductance in there and L is equal to 0.42 R squared C, you get the optimum rise time. And the guys from the Moore School didn't know that. So he gave me one weekend to design the gate. On Monday we built the gate, it was done. So then he said, design the standard flip-flop. After a while he gave me the whole memory. I built the world's first acoustic memory. Without other engineers. If you go down to the Smithsonian, it's down there. So step by step, we went from 4 parts, 3 diodes and a resistor, 5 parts and an inductor, to a flip-flop, to a memory, to, over the years I've designed very complicated stuff, but you do it step by step. And there's a price you pay for this, because if you're reasonably smart, then you're successful. When I was at Philco, my first job was testing capacitors. I hated it. I had been a Navy officer, I had 2 degrees from MIT, and I'm testing capacitors until I'm blue in the face. But I learned that they're all different. Gee, a 1 microfarad capacitor ain't a 1 microfarad capacitor. And a 10 microfarad electrolytic capacitor may be 100 or 5. And then, you begin to learn that when you design something, things ain't quite what you think they are when you're a student. So, the next thing they gave me was to test, I started testing radar cathode ray tubes. They had 2 spots. And I would turn a knob until I couldn't tell the difference between the 2 spots, and then write down the number. And I got cockeyed doing this. But These are very useful things to learn. Now, after a while, then I went to the Economic Computer Company and went up the line. But these basic simple things are very important. And so engineering, together with farming and a couple of other, is the heart of the economic strength of the country. And fewer engineers over the last 10, 15, 20 years have really gone into engineering. And those are the people who make the economic sense of the country.